Have you ever looked at a snowflake? Each one is a tiny masterpiece of nature. It has a beautiful repeating pattern, a perfect six-sided shape built from frozen water. Our universe is full of these patterns. From the spiral arms of a galaxy to the hexagonal cells of a honeycomb, order appears everywhere we look. These patterns are not just pretty. They tell us something profound about the laws of physics. They reveal the fundamental rules that govern everything, from the smallest atoms to the largest structures in the cosmos. Let's dive a little deeper into what makes a crystal a crystal. The key idea is periodicity. Imagine walking through an infinite orchard where the trees are planted in perfectly straight rows. This is exactly what it's like inside a crystal, but for atoms instead of trees. But what if a pattern could repeat in another dimension? Not just in space, but in time itself. A pattern that repeats over and over again, like a clock that ticks forever without any energy to power it. This idea is so strange, so counterintuitive, that for a long time most physicists thought it was impossible. In the last few years, scientists have discovered something truly mind-blowing. They have found a new kind of matter, a new state of existence that does exactly this. This is a space-time crystal. It's a discovery that forces us to rethink our understanding of reality. To understand why space-time crystals are so revolutionary, we need to talk about symmetry breaking. Imagine a pencil balanced perfectly on its tip. The slightest nudge will cause it to fall. When it falls, it will point in one specific direction. The initial perfect symmetry is gone. This process is responsible for creating the patterns we see all around us. When water freezes into ice, its molecules give up their random arrangement. Now let's apply this to time. The laws of physics themselves have a symmetry in time. A time crystal, however, breaks this very symmetry. It spontaneously chooses a specific rhythm. It breaks the continuous flow of time into discrete, repeating ticks. To make this new kind of time crystal, physicists needed to find a very special kind of system. A normal material, if you periodically push on it, will simply heat up. The loophole they found lies deep within the bizarre world of quantum mechanics. It's a phenomenon called many-body localization. In certain very disordered quantum systems, the particles can become trapped. It's as if each particle is isolated in its own little quantum prison, even though they are all part of the same system. This localization is the secret ingredient for making a driven time crystal. With a theoretical recipe in hand, the race was on to actually build one. The challenge was immense. The first successful attempt, reported around 2017, came from two independent teams of physicists. One team, led by researchers at the University of Maryland, used a line of just 10 ytterbium ions. These ions were trapped by electric fields, hovering in a perfect line in a vacuum chamber. Each ion acts like a tiny quantum magnet, or spin, which can point either up or down. A laser was used to push on these spins, trying to flip them. The system did not follow the rhythm of the laser. Instead, something remarkable happened. The entire chain of 10 ions began to oscillate, but at a completely different frequency. It had spontaneously chosen to move at exactly half the frequency of the drive. This was it. At the same time, hundreds of miles away at Harvard University, another team was taking a completely different path. Their material of choice was a diamond, but this wasn't just any diamond you would find in a jewelry store. It was engineered to be full of tiny imperfections. Specifically, it contained a high concentration of nitrogen vacancy centers. The Harvard team placed their special diamond in a device that could bombard it with microwave pulses. The vast collection of spins within the diamond began to oscillate in perfect unison, but they did not oscillate in time with the microwave pulses. They oscillated at exactly half the frequency. The creation of a time crystal was a monumental achievement in fundamental physics, but a new question began to surface. What can we actually do with them? When the laser was first invented in 1960, it was famously described as a solution looking for a problem. Today, lasers are everywhere. A discovery that began as a pure scientific curiosity has completely reshaped modern life. Perhaps the most exciting potential application for time crystals is in the field of quantum computing. The core problem is something called decoherence. The quantum bits are incredibly fragile. A time crystal could act as the perfect clock or timing reference for a quantum processor. Beyond quantum computing, the discovery of time crystals has profound implications for our fundamental understanding of the universe. For example, questions about the very early universe. In the moments after the Big Bang, the universe was in an extreme high-energy, non-equilibrium state. By building and studying different kinds of time crystals, scientists can probe the limits of this phenomenon. Ultimately, time crystals remind us that the universe is far stranger and more wonderful than we often assume. They are a testament to the fact that there are still new continents of knowledge to be discovered. The ticking of a time crystal is a quiet but profound signal, telling us that the quantum world still holds many secrets. We have journeyed into a strange and wonderful new corner of the cosmos, one that exists in the intricate dance of atoms in the dimension of time. The discovery of space-time crystals represents a profound shift in our understanding of what matter can be. The time crystal shatters this old paradigm. It is a form of matter that has its own internal clock. This journey from a wild theoretical idea to concrete experimental reality is a perfect illustration of how science works at its best. The existence of time crystals is no longer in doubt. They are real. We have created them in our laboratories. The quiet rhythmic pulse of the time crystal is an echo of a new reality, waiting to be found in the subtle depths of the quantum world. Every great discovery in science answers one question only to create a dozen new ones. The time crystal is no exception. What other exotic phases of matter are hiding in that non-equilibrium realm? The time crystal has taught us that we must be prepared to question everything. The universe has revealed another one of its secrets, a quiet pulse in the heart of matter. And as we continue to listen, there is no telling what other strange and wonderful music we might hear in the years to come.